You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the Moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the Moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the Moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the Moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the Moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the Moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the Moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the Moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the Moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the Moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the Moon, but also how it appeared on Earth. Anyway, what's all that water doing on the Moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the Moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The Moon barely tilts on its axis, only about 1 degree, so the sun never peaks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness. But some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels, while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, Shadow Cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.
August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now picture this. Future lunar settlers could tap into this water supply. that could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis II is set to carry astronauts to lunar orbit in 2024, and during Artemis III, which should take place in the mid-2020s, 2 astronauts will touch down near the moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned. This is a typical crater on the moon. It's here because, once upon a time, an asteroid crashed right into it. Yep, a lunar crater forms when an asteroid, meteoroid, or a comet slams into the moon's surface. And as you can see, it's happened a lot. But one crater formed in a very different way. But then, how did it form? Well, let's rewind a bit. There's a widely accepted hypothesis that the moon itself is a product of collision, just like all these craters. But that collision was way tougher. It happened over 4.5 billion years ago when a huge Mars-sized planet called Theia crashed into Earth. That event threw a bunch of debris into orbit. Eventually, it came together to form the moon. Now, for a while after that, the moon was basically a giant ball of lava. But because the early moon was very close to Earth, our planet's gravity kept squeezing it, making it even hotter. In the end, though, the moon drifted farther away, cooled down, and formed a rocky crust. Now, moving on, about 4.3 billion years ago, an asteroid the size of a small country, like Nepal, way bigger than the one that wiped out the dinosaurs, slammed into the moon's far side. It left an enormous crater called the South Pole Aitken Basin. It's up to 5 miles deep and about 1,500 miles wide. For comparison, that's roughly the distance from New York to Dallas and deep enough to swallow Mount Everest. Now, scientists think that impact may have dug up and scattered some ancient stuff from deep inside the moon, a mixture of materials nicknamed creep, short for potassium, rare earth elements, and phosphorus. It's like a chemical time capsule from when the moon was still a lava ocean. Now, you want to know the reason why this area could be even more scientifically interesting than we realized? You see, until recently, Researchers believe the asteroid came from the south, slamming upward and spreading a bunch of radioactive material, that very creep, around the crater's northern rim. But after looking closer, scientists realized the impact actually came from the north, which means all that valuable creep ended up on the southern edge instead. And guess what? NASA's Artemis II mission happens to be targeting that exact southern region. Researchers started questioning the old southern impact theory when they compared the Moon's crater with others across the solar system, mainly Mars's Hellas Basin and Pluto's Sputnik Basin. Here they are. See? All three have this bizarre teardrop or avocado shape, wide on one side and pointy on the other. And exactly that pointy end usually shows which direction the asteroid came from. In the case of the South Pole Aitken Basin, that means the asteroid hit from the north, not from the south. To confirm it, scientists dug into old data from NASA's Lunar Prospector mission. It orbited the Moon in 1998 to 1999. That spacecraft measured radioactive elements on the surface and found high concentrations of thorium, a key part of creep, around the basin's southwestern rim. Now, the Artemis III mission is NASA's big plan to put humans back on the Moon for the first time since 1972. If everything goes according to schedule, the launch is set for mid-2027, right after Artemis II wraps up. See, Artemis II, which is supposed to launch before April 2026, will be sort of a dress rehearsal. Astronauts will orbit the Moon without landing, just to make sure that all the systems work smoothly, a cosmic test drive. Artemis III is where things are going to get real. The astronauts are expected to land near the Moon's south pole, in one of 9 possible locations NASA has scouted out. The only problem is timing. Artemis III has already been delayed a few times, and so has Artemis II. Artemis I launched in 2022. It was an uncrewed test flight that went around the Moon and came back just fine. So, next up is Artemis II, which will take real astronauts further into space. Then comes Artemis III, the big one. Astronauts are supposed to hang out on the lunar surface for about a week doing sciencey stuff before heading home. After that, Artemis IV and V will build and expand a new mini space station orbiting the Moon. It's called Gateway. Think of it as a pit stop in space. Astronauts can dock there, live for short missions, do experiments, and prepare for landings. NASA's building it with help from the European Space Agency, Japan, and a few others. The astronauts are going to travel in the Orion spacecraft, launched by NASA's Space Launch System, a massive rocket taller than the Statue of Liberty and strong enough to fling people to the Moon. To actually land, they'll use the Human Landing System. SpaceX's Starship is supposed to take the first cruise down to the Moon's surface once it proves it can land safely. In the long run, NASA's not going to stop at the Moon. The big goal is Moon to Mars. Hopefully, we can use everything we learned from Artemis to build a lunar base and eventually send humans all the way to Mars. And who knows? Maybe when people land on the Moon, they'll be able to figure out another unsolved mystery: flickers, glows, or beams of light that sometimes illuminate our satellite. Let's dig deeper into this mystery, shall we? On the night of April 19, 1787, astronomer William Herschel spotted something weird: a bright light glowing on the dark part of the new moon. It shone for hours and was almost as bright as the Orion Nebula. What he saw probably was what scientists now call a transient lunar phenomenon, or TLP. Basically, quick little flashes or color changes on the moon's surface. TLPs can look like glowing patches, reddish or purple spots, or even hazy clouds that suddenly appear and fade away. Over the last 2,000 years, people have recorded around 3,000 of these strange moon flashes, using telescopes, cameras, or sometimes just their own sharp eyes. So, what's really going on up there? Well, there's no single answer. Lots of different things can cause TLPs. from meteor impacts to gas releases or even electrical activity. The length of the flash, which can last anywhere from a split second to several hours, gives scientists clues about what's behind each mysterious lunar light show. The super short flashes lasting less than a minute are most likely caused by tiny space rocks crashing into the moon. Even a meteoroid, the weight of a billiard ball, can hit the lunar surface hard enough to make it glow for a split second. The heat from the impact makes rocks shine and then quickly fade as they cool down. For a long time, scientists suspected these quick flashes were caused by meteor hits, but they couldn't prove it until the 1990s, when high-speed cameras finally became common in lunar research. Even then, it wasn't easy to confirm. Short flashes could have just been camera glitches or electric noise. The only way to be sure was to catch the same flash from two or more places at once. Well, that happened for the first time during the Leonid meteor shower in 1999, when scientists recorded real impact flashes on the moon. Later, we got more proof that the moon was often peppered with space rocks. While the flashes seem to cluster in certain areas, like Oceanus Procellarum, one of the moon's big dark plains, that's likely just because of where scientists have focused their cameras. A 2024 study showed that meteoroids actually hit the moon evenly everywhere. Now, flashes that last a few minutes are probably caused by something totally different: gas leaks from inside the moon itself. Studies from 2008 and 2009 found that when gas like radon builds up under the lunar surface, it can suddenly burst out. Hey, I know how that feels. And when this radioactive gas escapes and decays, it gives off a faint glow we can see from Earth. Interestingly, those glowing spots often line up with areas where scientists have already found higher radon levels. Then, there are the long-haul lights. They stick around for hours, like the bright glow William Herschel saw back in 1787. A 2012 study suggested those could actually be caused by solar wind, a stream of charged particles coming from the sun. When that solar wind hits lunar dust, it can charge up the particles and toss them into the air, well, into space, creating massive dust clouds up to 60 miles high. These floating clouds might bend or reflect light from stars or planets nearby, making it look like the moon itself is glowing. So hopefully, we'll get the answers once the Artemis mission lands and starts its exploration. Hey, I can hardly wait.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago, but they appear much younger than expected. Typically found in clusters of 10 to 40, they're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger. And the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the Moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the Moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active Moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the Moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the Moon. In its early years, the Moon was just a molten world, shaking from intense volcanic and seismic activity. So, the Moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the Moon, but for Earth too. After all, the giant impact that formed the Moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The Moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the Moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the Moon's continued activity. As it cools, the Moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large, dark patches on the Moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the Moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the Moon actually affect humans? In a sense, it can. The Moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the Moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the Moon's surface, grinding much of it into powder. Unlike Earth, the Moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show. The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 230,000 miles apart, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates and it causes a centrifugal force. And then, the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, tilts more or less, and causes changes in ocean tides. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon? They also have that specific red color, thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different materials the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust. But apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process, and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the Lunar Anthropocene. It's like an analogy with Earth's Anthropocene, a period when human activity made an impact on the planet. It's not like we can choose a certain starting point when such an activity began. But we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the Lunar Anthropocene to remind ourselves we have to be responsible and take care of our heritage. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green. But it's possible that we saw it as more yellow when we were younger because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yep, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon. And that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere, and that's why you see that specific color. The moon's volcanoes are not dormant, and they can erupt any minute. For years, we lived knowing nothing about it, but now it's officially proven thanks to China's Chang'e 5 mission's shocking discovery. The lunar soil samples it brought back to Earth contained something absolutely unexpected, hinting that volcanic eruptions may have occurred on the moon as recently as 123 million years ago. Geologically, that's practically yesterday. But the big question is, are we safe down here on Earth? We've long known that the moon was once volcanically active due to the dark regions, lunar maria, on its surface. These maria, the dark plains that give the moon its characteristic markings, are ancient lava flows that date back to around 3 to 3.8 billion years ago. Until recently, scientists thought that those ancient flows marked the end of the moon's volcanic activity. But the Chang'e 5 mission brought back lunar soil that included several microscopic glass beads, and 3 of them in particular revealed an extraordinary story. They formed around 123 million years ago from volcanic eruptions. An uncertainty range is a mere 15 million years. The discovery of those tiny beads is super important because of their composition and rarity. Measuring between 20 to 400 microns, which is smaller than a grain of sand, these beads are volcanic in origin. And this fact sets them apart from most other lunar glass beads, which typically form due to meteor impacts. Impact events on the moon create glass by melting surface rock with incredible heat and pressure. The result is tiny glass beads scattered all over the landscape. Yet, the volcanic beads identified in Chang'e 5's sample were formed by magma erupting from beneath the moon's crust and cooling it into glass as it reached the surface. By using uranium-lead dating, which measures the decay of uranium into lead within the beads, scientists managed to pinpoint their age with striking accuracy. The results suggest that the last known volcanic activity on the moon happened within the past 200 million years, making it a recent event in the moon's long history. This discovery also aligns with prior observations of unusual surface features known as irregular mare patches. Those are smooth mounds surrounded by rocky terrain. They were first spotted by NASA's Lunar Reconnaissance Orbiter in 2014. These patches appear much younger than other lunar features, potentially formed by volcanic eruptions less than 100 million years ago. Before Chang'e 5's glass beads, these irregular mare patches were among the best evidence of recent volcanic activity on the moon. Yet, without confirmation, their origins remain uncertain. And now, the glass beads confirm volcanic action. The findings raise new questions about the moon's inner workings. In particular, how could it retain enough heat to sustain volcanic eruptions? We thought that the moon had cooled significantly after its formation 4.5 billion years ago, which made it volcanically inactive. And without tectonic activity or an atmosphere, the moon should have shed its internal heat long ago. Yet the beads suggest the possibility of some localized heat sources within the moon's mantle. Scientists think that heat-producing elements such as potassium and thorium might be creating small, warm pockets which generate enough heat to melt rock and trigger isolated volcanic eruptions. But wait, beyond rewriting the moon's history, this discovery adds an intriguing twist to ongoing studies of transient lunar phenomena. These sightings, often reported as ghostly glows or hazes by amateur astronomers, remain unconfirmed by scientific probes. Some experts just dismiss them as illusions caused by Earth's atmosphere. But if the moon has small pockets of volcanic or outgassing activity, TLP might have a real basis. Gases emitted from beneath the surface could explain such mysterious glows and possibly be a hint of residual volcanic action on the moon. Now, if volcanic activity still lingers on the moon, this might have exciting implications for future lunar missions. In the coming decades, astronauts might be able to use volcanic heat for generating power, melting ice into water, or even warming bases built into the frigid lunar surface. But recent geological discoveries aren't limited to Earth's natural satellite. We learn more about volcanic moons beyond our solar system too. The detection of a possibly volcanic exomoon orbiting exoplanet WASP-49b around 635 light-years away means that volcanic activity may be a common feature among moons. Up until now, Jupiter's moon, Io, held the title of the most volcanic body we know about. But researchers at NASA's Jet Propulsion Laboratory may have found a new candidate. This potential exomoon came to light when scientists observed a cloud of sodium gas around the exoplanet. But the thing is, sodium clouds are unusual in planetary atmospheres and can suggest volcanic activity. The sodium cloud near WASP-49b had a bizarre, unexpected behavior. It was moving erratically, shifting size, and occupying a space too large to be explained by the exoplanet's own atmosphere. Scientists thought the cloud could actually be generated by a volcanically active exomoon in orbit around WASP-49b. Volcanic moons like Io are known to release gases such as sulfur dioxide, sodium, and potassium, which form massive clouds around their parent planets. Io, for instance, regularly produces vast amounts of gas that form a cloud encircling Jupiter, up to 1,000 times the size of the gas giant itself. If something similar occurs near WASP-49b, the gas cloud could be a clue to volcanic activity on an exomoon orbiting the planet. Observations from the European Southern Observatory's Very Large Telescope in Chile seems to confirm this theory. The sodium cloud around WASP-49b is positioned high above the exoplanet's atmosphere and behaves in ways that don't match the exoplanet's 2.8 Earth day orbit. This could suggest that it originates from a separate body, likely a volcanically active moon. Additionally, WASP-49b and its host star consist primarily of hydrogen and helium, which makes the sodium cloud even more unusual. The observed rate of sodium release, over 220,000 pounds per second, can be a sign of an immensely powerful volcanic source. If scientists verify the existence of this exomoon, it would be the first discovery of a volcanic exomoon. Back in our solar system, Io remains the main space object, helping us understand volcanic moons. Recently, NASA's Juno spacecraft provided some of the closest images of Io since the Galileo mission over 25 years ago. Io's intense volcanic activity is caused by tidal heating, the result of the gravitational pull of Jupiter and nearby moons, like Europa. This tug-of-war generates immense friction within Io, producing heat that fuels continuous volcanic eruptions. One of Juno's most exciting recent findings was a new volcano that appeared just south of Io's equator. Juno's images show a large, complex volcanic region, approximately 111 by 111 miles in size. The craziest thing? It wasn't there when Galileo imaged the same spot in 1997. This new volcano formed near the previously known volcano, Canahekale. Researchers say that this new volcanic structure is a great change that highlights the dynamic nature of Io's surface. Io's equatorial region is home to most of its volcanoes because of the concentrated tidal heating it experiences. The most powerful eruptions emit sulfurous gases and produce bright lava flows. They cover the moon in colorful, sulfur-rich deposits. JunoCam's image, taken from about 1,570 miles away, shows Io dramatically lit by sunlight reflected off Jupiter. And you can see a stunning view of its constantly changing volcanic surface. Despite these detailed observations, there are still many mysteries about Io's volcanism. Scientists are particularly curious about how tidal heating affects Io's interior, and whether it has a subsurface magma ocean. Plus, researchers try to understand what triggers different types of eruptions. For example, plumes versus lava flows, and how volcanic gases shape Io's surface and thin atmosphere. The study of volcanic moons from Io to the possible exomoon near WASP 49b sheds light on how tidal forces create volcanic activity in different moons. In icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, creating potential habitats for life. But for Io without an ocean, the same forces instead generate powerful volcanic activity. Plus, if volcanic exomoons do exist, like the one possibly orbiting WASP 49b, we might soon discover more volcanic bodies across the galaxy.
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush. Because apparently, precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder, why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up. Hey there! Yeah, you, my friend, on the other side of this screen. You're listening to my voice and watching this video, which was created in certain computer programs and is streaming on the device of your choice. So, perhaps there's not much difference between you and me, because there's a chance that you're also created inside a special app. You don't believe that? Well, let's try to figure out this crazy theory. So, meet Dr. Melvin Vopson. He explores the idea that our universe is a computer simulation. Yes, you've probably heard it before. Elon Musk has made similar statements, but what exactly do these people mean? Melvin Vopson believes that gravity is a life hack that the universe uses to reduce the load on its computing processor. It's like programs for compressing files on your computer, only on a gigantic scale. Now, what is gravity? In simple words, it's the force of attraction between any objects having mass. Our planet is round and doesn't break up into billions of pieces because of gravity. We walk on the ground and don't fly off into the sky because of gravity. The phone is lying on your desk thanks to, say it with me, gravity. The Moon orbits the Earth following the same trajectory. The planets of the solar system travel in the same orbits around the Sun. Almost the entire universe strictly adheres to the laws of physics, and one of the greatest of these laws is gravity. I don't say the whole universe, because there are unknown things, such as dark matter and the like, that we don't know anything about. So gravity helps to keep order. But then, what does a computer program have to do with it? There are tons of different objects in the universe. Let's say our planet consists of the core, rocks, dust, air, various gases, trees, and a billion other things. Without gravity, all these things would fly away in different directions. Each of them has its own speed, size, and density. All this is a huge amount of information. But the force of gravity unites them into one object, the planet. And when all these billions of things are together, it's easier for the universal computer to process and read information. How about another example? Snowflakes have a remarkably similar shape. The waveform is nearly the same. The appearance of galaxies in distant space seems to be drawn according to a single pattern. And there are a lot of such symmetries in nature. And almost all of them are symmetrical thanks to gravity. What if this similarity is just another example of data optimization? Imagine if snowflakes looked different. It would be difficult for the computer to process each shape. But gravity forces all this matter to reduce the load on the processor. Gravity organizes and structures the universe, just like the archiver program on your computer. But why is this necessary? Well, in the case of the computer, data compression helps save space and improve the work of the processor. In our universe, everything seems to be working stably. It remains organized. Dr. Vopson suggests that all the elementary particles in our universe, such as atoms, electrons, photons, and the like, are tiny building blocks that contain information. It's like the cells inside our body that contain DNA. The scientist also draws an analogy with computer data. Any picture, video, game, or anything else on our screens consists of tiny bits of information in the form of binary data, ones and zeros. Our universe can work in the same way. If there's no information in a cell, it is zero. If there is matter inside, it's a unit. This is the principle used to develop computer games, VR apps, and complex simulations. But unlike computer programs, a cell in our universe can hold more than one particle. Thanks to this ability, particles can get together inside this cell. In terms of performance and energy savings, it's much easier to calculate the location and momentum of a single large object in space than many smaller disconnected objects. Gravity supports this optimization process. Of course, all this is just speculation, and scientists don't have any unmistakable evidence to support this theory. But there's one more thing that may indicate that we live in a simulation. You've probably heard of the observer effect in physics. When you observe the tiniest particles, like photons, they behave in a certain way. But when no one is watching them, they behave differently. This is how pixels behave in a video game. Imagine that you're riding a motorcycle while playing a game. There's a forest ahead of you. You see well-drawn trees that look like real ones, but then you stop and quickly turn in the opposite direction. If your computer is not enormously powerful, you may notice that the textures are loaded with a delay of a fraction of a second. If you're looking at a city, at first it's just the outline, and then you start seeing houses and lights. This happens because when we're not looking at the city, the computer doesn't load its textures to reduce the load on the processor. What's the point of wasting gigabytes of data if the player doesn't interact with the city in any way? But when you do look at the city, the processor shows it in all its beauty. And while you can see the streets and buildings, the forest disappears behind you until you look at it. The smallest particles of our universe act similarly. They stay unloaded till you watch them. The theory is entertaining, but there's one nuance. Photons and other tiny particles behave differently when you're not observing them, not because the universe saves data, but because the observer influences the behavior of particles. That is, while observing them, you use your eyes or lenses or some kind of device and detector. The very fact of observation changes matter, which is why photons behave this way. So, we don't know yet whether our universe is modeled or not. But what is the difference between a simulated computer program and the real world? Maybe the reality of the world is meant to be modeled inside a super powerful program. And if we are part of this world, then we are also like programs? In this case, the world is very real to us. It's perfect for us. Now imagine you take a computer character from a video game and place them in our reality. They simply can't exist in our world. They are much more comfortable living where you got them from. The world of the video game for them means the same as our world means for us. So, if there's a reality beyond our universe, then think twice. Would you like to get there? The human brain is unlikely to be able to perceive another reality. And if it tries, where is the guarantee that it won't go crazy? So, it's better to enjoy our universe. And don't forget that there's a whole universe inside each of us. No, seriously, where are the limits to your imagination? You can imagine absolutely anything in your head. A giant ship with long spider legs moving through a desert or rain where tiny Eiffel Towers fall to the ground instead of raindrops. There are trillions of possibilities in your imagination. But besides that, there are also feelings and emotions, joy, irritation, love. Yeah, you can say that our feelings are the result of chemical reactions in the brain. But don't you think there might be something more behind it? For example, you see a homeless guy. You give him some money and food. You show you care, thanks to the neurons responsible for empathy and feelings of mercy. But what if you're going home after a dreadful day at work and see that homeless person again? You're irritated, tired, and the neurons responsible for empathy are disabled. But even so, you can still show care for this homeless guy and give him food. That is, you do it regardless of the chemical processes in your brain. And this is just one example out of millions. Is a computer program capable of such a thing? If we live in a simulation, and if we're programs, then we are incredibly complex, advanced, and beautiful programs. And how do such perfect programs differ from what we call real in our heads? Although the word programs is not appropriate here, we are creations. Then, who is the creator? Or is there such a thing? Well, hate to stop here after asking the big metaphysical question, but hey, I gots to go.
In 2024, Earth was joined by a mini-moon that orbited around our planet for 2 months. It hung around, made a few laps, and then, like every polite guest, it left. It went back to resume its trip around the Sun. However, astronomers now say another rock has been tagging along with Earth not for weeks, but for 6 decades. It's rare and strange, now being classified as a quasi-moon. But what exactly does that mean? Is it like a backup satellite? Unlike our cool and mysterious moon that illuminates our nights and affects werewolves, a quasi-moon doesn't circle Earth. Instead, it orbits the Sun, but it does so almost in perfect sync with us, like a runner doing a marathon with you that keeps a similar pace. Space only seems calm. It's actually pretty chaotic. The Sun, the Moon, Earth, and even other planets are constantly tugging on each other and smaller objects like these rocks. Most asteroids can't hold this delicate balance for long. They either get nudged into a new orbit, pulled closer to Earth, or flung out into the vast reaches of space. That's why we're lucky to spot more than 1 or 2 at a time. Most just can't keep the balance. They belong to a bigger family called co-orbitals. In fact, astronomers group them into a few types based on how they move relative to Earth. But unlike the real moon, that's been our companion since the very beginning, these visitors don't stick around forever. Some hang with us for a few decades, others for centuries, before drifting away because the gravity of some other space object. Kinda like a dog running to your neighbor after smelling bacon. One other thing about quasi-moons is their size. Most are tiny, building-sized or even smaller. They're also so dim that they can hide in plain sight among stars. Still, they're important. By studying them, astronomers learn how small near-Earth objects move and how long they can stay caught in Earth's gravity. Quasi-moons are closer than other asteroids on the same path, and it would be easier to reach them. One day, they might be used as stepping stones in space exploration. Earth has had a few of these tag-alongs before. One of the most famous is 2016 HO3, nicknamed Earth's Constant Companion. It's only about 300 feet wide, but it's been keeping pace with us for nearly a century. Researchers say it might keep up for centuries more. But what about the most recently discovered one? The researchers named it 2025 PN7. Like we said, it's already been with us for 60 years and will likely stay for around 68 more. For a long time, it remained undiscovered because of its tiny size, only about 62 feet across, which is about the length of a bowling lane. This also answers the question of whether you could see it yourself if you knew where to look. Its backstory is a bit of a mystery. Astronomers haven't figured out its composition yet. Right now, all we know for sure is its trajectory. Some quasi-moons are just near-Earth asteroids that fell into a perfect orbit. Others seem like they could be chunks of the moon itself. For instance, there's another quasi-moon named Kamo'olawea that reflects light in almost the same way as the lunar rocks we brought back during the Apollo missions. Because of that, some researchers think it might actually be leftover from a huge impact that happened long ago. There's also 2024 PT5, a temporary mini-moon from the end of last year. Tests showed that its surface looked like lunar basalt, suggesting it probably came from the moon. So how do these quasi-moons pull off their cosmic balancing act? That's because it's just an orbital illusion. Remember, PN7, like other quasi-moons, isn't actually circling our planet. To us, it looks like the rock is scribbling lazy loops around Earth's path, like doodles in space. Yet it never lags too much or gets too far. Astronomers call this a one-to-one resonance. In plain English, it makes a lap around the sun every time Earth does. Another fun question. If these fake moons are so close to Earth, why don't we just pull them in with our gravity? Especially since they're tiny and seem so near. That's because even though they belong to a group called near-Earth objects, quasi-moons are not that close. Our moon is hanging out about 239,000 miles away. These companions, though, are flying around the sun millions of miles out, way beyond Earth's gravitational pull. That pull exists within an area called the Hill sphere, which is where Earth's gravity is stronger than the sun's. Think of Earth's gravity as a bubble with a radius of about 1,000,000 miles. Anything inside can get caught, like the real moon. Step outside, and the sun takes over. This is exactly what happened to PT5, which was our legit satellite for 2 months in 2024. It dipped inside the Hill sphere, and Earth's gravity took over. Once it happened, this object became known as a mini-moon. But because it was small and moving fast, it eventually slipped back out of that bubble, and the sun's gravity pulled it away again. One other type of co-orbiter, aside from quasi-moons and mini-moons, is the so-called horseshoe orbiters. These space rocks don't stray far, but from Earth's point of view, they seem to swing ahead of us, slow down, then drift back behind, and repeat. It's like an undercover cop tailing you in traffic, but constantly switching lanes and doubling back so you don't notice the pattern. If you trace their motion from Earth, over time, it forms a giant horseshoe shape, hence the name. And these are just the main co-orbiters. There are actually more. Way ahead of us and way behind us in space, there are a few quirky rocks called Trojans. They're not just following right next to Earth like quasi-moons do. Instead, they found 2 special hiding spots. One 60 degrees in front of us and one 60 degrees behind. Imagine riding your bike and having a friend way ahead of you and another one way behind, both keeping the same speed. That's what Trojans do. Those spots are called Lagrange points, cozy hangout regions where the gravitational pulls from Earth and the sun balance out perfectly. When they find themselves in one of those areas, they could be staying there for millions of years without drifting away. Jupiter, for example, has tons of these freeloaders. Earth has only a few. Then there are tadpole orbiters. Instead of sitting perfectly still in a Lagrange point, they wobble around it in lazy bean-shaped loops. And if that's not confusing and overwhelming enough, there are also jumping Trojans, the indecisive ones. These guys can't pick a side. They'll spend a few thousand years staying in the front hammock, then slowly drift to one behind us and back again. Rare, weird, and kind of awesome. So even though Earth only has one big moon in the sky, we've actually got a whole gang of intrusive space tag-alongs. Some loop, some trail, some hide in the corners. Now let's recap the superpowers of our moon. It can affect tides, slow down Earth's rotation, and even help stabilize our planet's tilt. Without the moon, our days would be shorter, our nights darker, and the seasons way more chaotic. The moon also acts like a giant shield, sweeping up or deflecting some space rocks that might otherwise smack into Earth. And let's not forget its cultural influence. It's been inspiring myths, calendars, love songs, and millions of melancholic walks in the middle of the night. Fake moons can't compete. However, they are important in their own way. Each new quasi-moon we find helps us understand how these little rocks survive in all that cosmic chaos. By learning about our environment, we also learn something about ourselves. They sharpen our detection skills and help us improve our models. So while they'll never shine in the night sky, they still play a quiet role in helping us understand our quirky cosmic neighborhood.
Well, guess what? Earth has not one, but 7 moons. At least 7. There might be more. And this knowledge changes the whole picture of the world, doesn't it? Does it mean we're going to colonize not 1, but 7 space bodies and have 7 lunar bases? Will we have a choice on which natural satellite to spend our space vacation in the future? Well, here's the thing. These extra moons are kind of different. They're called mini-moons. Now, there's no official definition for a mini-moon because, of course, scientists can't agree on anything. But the general idea is it's a space rock that gets temporarily stuck in Earth's gravity, does at least one full loop around us, and at some point swings in pretty close, like within 4 moon distances close. Basically, if it gets close enough to freak out astronomers, it counts. Our Earth gets these tiny moons from time to time. They swing by, hang out for a bit, and then head out to orbit the Sun. Every now and then, chunks of space debris get caught by Earth's gravity and starts orbiting us for a while, just like they're crashing on our couch before hitting the road again, sort of cosmic speed dating. Scientists thought that most of these mini-moons came from the asteroid belt, a giant pile of space rubble between Mars and Jupiter. But some recent discoveries are kind of throwing a wrench in that. It turns out that some of these tiny moons might actually be pieces of our own moon. One famous example, back in 2016, a telescope in Hawaii spotted a weird little object hanging out near Earth. They named it Kame'o'olea, which to me sounds like a cool vacation spot. But it's really a 328-foot wide space rock that orbits the Sun in sync with us. Later studies showed it probably broke off the Moon between 1 and 10 million years ago, I wasn't around then, when something massive slammed into it and made the Giordano Bruno crater. And just recently, another object popped up, 2024 PT5. And guess what? It also looks a lot more like a piece of the Moon than your typical asteroid. Naturally, researchers couldn't resist running the math. One of them, Robert Jedicke, also known as the guy who's basically the mini-moon expert, and his team did several simulations to figure out how often moon chunks might end up orbiting Earth. Turns out, a lot of that debris can actually get caught by Earth's gravity, at least for a little while, and about 20% of it could become legit mini-moons. Now, the best guess is around 6 or 7 little lunar-born space pebbles might be orbiting Earth right now. Not forever, though. These guys have commitment issues. The average mini-moon sticks around for about 9 months before peacing out. And because new debris is always drifting into Earth's neighborhood, the squad keeps refreshing. But here's the thing. These numbers are super shaky. Jedicke literally said the uncertainty is ginormous, and I'm doing air quotes, which is the most sciencey way of saying, we're guessing here. There are just too many unknowns, like how big the moon explosions are, how fast the pieces fly, and whether our telescopes are even good enough to see the tiny stuff. So yeah, the prediction might be totally wrong, but that's science for you. You make a guess, someone proves you wrong later, and we all get smarter in the end. In any case, little mini-moons are super annoying to spot. They're usually the size of a car or an SUV, somewhere between 3 and 7 feet wide. It might sound big when you're parallel parking, but in space terms, that's basically a breadcrumb. But an even bigger problem is that they're tiny and fast. For us to see them, they have to swing pretty close to Earth so they reflect enough light. But when they're that close, they're also zipping across the sky like they're late for something, which makes them really tricky to catch even with fancy telescopes. That's one of the things that makes scientists worry about mini-moons. What if one of them eventually ends up in Earth's atmosphere? Then it could be the Chelyabinsk event number 2. You see, it was a quiet morning in Chelyabinsk until it wasn't. There was a flash of light so bright it outshone the sun, followed by a deafening sonic shock that rattled the skies and shattered reality, along with a few thousand windows. It happened on February 15, 2013. Without warning, a space rock the size of a house burst into Earth's atmosphere at over 11 miles per second. About 14 miles above the ground, it detonated mid-air, unleashing an immense amount of power. Glass rained down in homes, schools, offices. Over 1,600 people were injured, most of them by flying shards. And it wasn't even a big asteroid, just a cosmic pebble compared to the ones lurking out there. Luckily, according to Jedicke, modern sky surveys are surprisingly good at spotting stuff that small, even from millions of miles away. But there's a catch. These things move so fast they don't show up as dots in images like normal space objects. They leave streaks, and computers intensely dislike streaks. Those motion trails are harder for algorithms to recognize, so these tiny moons often just slip by unnoticed. Luckily, it's not all doom and gloom. The researchers point out that we did manage to spot one, 2020 CD3, even though it was only visible on 2 out of 1,000 possible nights. That's like finding a needle in a haystack while the haystack is spinning. But once we know where a mini-moon is, it's way easier to track it. And here's where things get exciting. Those tiny visitors might actually be useful. Since they come so close to Earth, they'd be way cheaper to reach than flying all the way to the asteroid belt. So space companies might one day try to snag one and mine it for minerals and stuff. Scientifically, mini-moons are also kind of a big deal. They could help us understand how the solar system was built and how it's still changing. Studying how chunks of the moon got blasted off and turned into orbiting debris might even help us figure out what kind of damage an asteroid could do to Earth. So yeah, these little guys may be fast, hard to find, and kind of flaky, but they've got loads of secrets to spill. By the way, Earth might have had 2 real moons once, and those were not mini-moons. One of them was our familiar one, and the other one was a smaller buddy moon tagging along. Sadly, things didn't end well for the little guy. Scientists have been wondering for years why one side of the moon, the one we always see, is smooth and flat, while the far side, the one that never shows its face, is all bumpy, crusty, and way thicker. Looks like the moon has a good side for selfies and a rough don't-take-my-picture side. So, according to a new computer model, that lopsidedness might be the result of a slow-motion cosmic fender bender. The theory goes like this. Millions of years ago, our moon had a smaller moon sibling cruising along with it in space. Everything was chill like for 80 million years. Both moons had the same vibes, similar makeup, same color, just one was 3 times bigger than the other. Then, gravity happened. As the moons drifted further from the Earth, the sun's gravitational pull stepped in, messed with the smaller moon's path, and eventually sent it crashing into the far side of the bigger moon. This wasn't a huge action movie explosion. The speed was more like a slow but firm crash, not fast enough to melt rock, but just strong enough to squish one moon into the other like cosmic Play-Doh. The smaller one didn't leave a big crater. It basically smeared itself across the far side, leaving behind that mountain-heavy terrain we see today. After the crash, space got really messy. Trillions of tons of moon debris got thrown into orbit, and for a few days, the whole system was just dust, rocks, and chaos. And Earth? It got pelted with moon chunks for up to 1 million years afterwards. Some of those space rocks were the size of cities. So, in the end, our natural satellite may be a mix of two moons mashed together, one face smooth, one face forever marked by its lost twin. It's kind of tragic, kind of epic, and explains why the moon looks like it lost a fight on one side. So, you kind of forgot to duck, huh? So, check out this creature. What do you think this thing is? Is it a plant, an animal, or maybe even some kind of wild fungus? At first glance, this fossil could pass for any of those ancient life forms. And honestly, scientists have been scratching their heads over it for over 150 years. But now, it looks like we might finally be cracking the case on this unknown species discovery. A long time ago, during the Devonian period, plants were just starting to grow on land. The tallest trees were only a few feet high, and animals hadn't even evolved backbones yet. Back then, massive natural towers up to 26 feet tall and 3 feet wide, looking like branchless cylindrical tree trunks, were rising from the ground. Hey, what a contrast with trees back then. When scientists first discovered fossils of those towering organisms, they were totally confused, as these strange prehistoric creatures didn't look like anything they'd seen before. Some thought they were weird cone-bearing trees. Others guessed they might be underwater plants like giant seaweed or lichens, which are partnerships between fungi and algae. The mysterious objects received a name, prototaxites. When scientists studied them up close, their internal structure reminded them of a bunch of different things. They couldn't believe a 20-foot-tall fungus or algae could be real, but that's what the fossils showed. Then most scientists decided that prototaxites were giant fungi. But still, something didn't feel right about it. In 2007, they decided to finally get the prototaxites mystery explained and ran a chemical test on the fossils. So they looked at the types of carbon inside them and compared them to regular plants from the same time. If prototaxites were plants, the carbon ratios would match, but they didn't. That means prototaxites weren't plants, and they receive carbon in a different way, not by photosynthesis, but probably more like fungi do. But then again, they look nothing like the mushrooms we know and love today. Prototaxites were giant, likely the largest living things on land at their time. And even if these strange prehistoric creatures were some fungi of their sort, then it's weird they don't have any living relatives today that would resemble them. So, if we put all this together, it looks like prototaxites are an entirely different and previously unknown life form that didn't leave any offspring. Now, prototaxites aren't the only unclassified organisms on Earth. About 600 million years ago, there were no fish, no sharks, no crabs. Just simple life forms like algae and bacteria drifting through calm, shallow seas. But some seriously strange creatures, completely unlike anything we see today, lived among them. They looked like underwater ferns, stood perfectly still, and absorbed nutrients straight from the water. These bizarre life forms were rangeomorphs. They ruled the oceans that were thick with nutrients back then. So rangeomorphs didn't need mouths, eyes, or muscles to survive and just soaked up whatever they needed. Some of them were as small as a finger, and others grew as tall as 6.5 feet. But as Earth entered the Cambrian period, the oceans became much more competitive. Fast-swimming creatures with limbs, eyes, and jaws showed up and ate the same food faster, and maybe even ate the rangeomorphs themselves. The chemistry of the oceans also started to shift, and the nutrient-rich waters became more like today's oceans, where food floats around in particles that active animals scoop up. So the rangeomorphs vanished forever, but scientists still find their fossils all over the world, preserved in ancient rock. They had an incredible fractal design, a pattern that repeated itself at every level, from the smallest branches to the full body. Using fossil clues, researchers built 3D computer models of what rangeomorphs looked like. They found out that these strange prehistoric creatures filled their space in a nearly perfect way. They were like optimized living sponges. But scientists still can't agree on where exactly rangeomorphs fit on the tree of life. At first, they argued over whether they were plants, animals, fungi, or something completely different. Now, most agree they were primitive animals, though they were so different that they might deserve their own unique branch, what scientists call a clade. And then there was Dickinsonia, another prehistoric creature that was so strange that scientists couldn't even agree on what it was for nearly 100 years. Some thought it was a giant single-celled amoeba. Others thought it was a type of lichen, or maybe a failed evolutionary experiment. This bizarre life form lived about 558 million years ago, long before dinosaurs, sharks, or even insects showed up. After many years of studies, Australian researchers finally got proof that Dickinsonia was an animal, and possibly the oldest one scientists have ever found. They solved the mystery thanks to really well-preserved fossil fat molecules stuck in the rock near the White Sea. These molecules were a type of cholesterol, the kind of fat found in animal cells. If cholesterol is present, it almost certainly came from an animal, sort of like animal DNA. Dickinsonia lived millions of years earlier than scientists had previously thought, and didn't look anything like modern animals. It had no head, no mouth, no arms, no legs, and definitely no organs. It was oval-shaped, like a giant pill bug or flattened jelly bean, with weird ridges running across its body. Some were tiny, but others grew up to 5 feet long, the size of a person. It didn't swim or walk, but was just lying on the seafloor, soaking up nutrients from the water or absorbing stuff through its skin. It was tricky to identify because most fossils came from high-pressure rock, where heat had destroyed all the delicate organic stuff scientists needed to study. To get to the good fossils, researchers had to rappel down 300-foot cliffs, dig out huge blocks of sandstone, throw them down, wash them, and then repeat the process. And inside one of those sandstone slabs was the fossil that changed everything. That helped finally confirm that Dickinsonia was an animal, which proves that complex animal life existed before the Cambrian diversification, where tons of new animals with bones, eyes, and limbs suddenly appeared. Scientists think the spot where they found these fossils might hold more clues about ancient life. For a long time, scientists had no clue what other group of ancient life forms, slime molds, were. These weird jelly-like blobs that pulse and ooze on rotten logs and forest floors aren't fungi like mushrooms, though people thought they were for years. It turns out they're more like amoebas, squishy, single-celled organisms that can move around. There are over 900 species of slime molds all over the world. You'll find them in soil, leaf litter, and especially on decaying wood. Scientists found them trapped in amber from 100 million years ago, and it looks just like modern slime molds. Scientists still know very little about how slime molds interact with other species, what role they play in ecosystems, or how they think without a brain, nerves, or a control center. But somehow, they can make decisions and adapt to their surroundings. It makes them a lot like social insects, like ants or bees, where no single bug is in charge, but the colony still works together as a smart group. Even without brains, scientists have trained slime molds to solve mazes just by responding to chemicals and learning from their environment. One way these organisms learn is through a process called habituation. It's sort of like how you get used to cold water after jumping in a lake, or stop noticing an annoying buzzing noise after a few minutes. That's your brain helping you tune out something harmless. Some slime molds can do this too. If they get in nasty conditions, like salty, dry, acidic environments or chemicals, they'll avoid them at first. But if there's food on the other side, they'll eventually get used to it and push their way through. And if you let slime mold go dormant and wake up a year later, it still remembers how to deal with salt. They even seem to be able to decide where to go based on where they found food in the past. With more and more unknown species discoveries, scientists can paint a better picture of Earth's biological past.
We all grew up believing that Stonehenge is the world's most ancient observatory, but now it has some serious competition for the title. Nabta Playa was built more than 2,000 miles away in southern Egypt and thousands of years before Stonehenge and even the pyramids of Giza. In 1973, a Bedouin guide stumbled upon a strange group of huge stone formations while crossing the Sahara Desert. He led American archaeologist Fred Wendorf to the site, located about 60 miles from the Nile. Wendorf's friend and colleague claims the team found the stones while stopping for a bathroom break in the desert. Either way, what they found changed history. At first, Wendorf thought the stone structures were just natural formations. But then it hit him. This area was once a lake, meaning no natural rocks should even be there. He kept coming back to the site for decades, and by the early 1990s, his team finally uncovered a circle of stones that seemed to line up with the stars in a way no one could explain. After 7 long years of trying to crack the mystery of the site, Wendorf reached out to an expert in archaeoastronomy. They study how ancient people used the stars. One evening, while the expert sat in the cool desert sand staring at the stones, he realized that they formed a pattern radiating outward from a massive burial mound. One by one, as they dug into the sediment, the buried megaliths started lining up like spokes on a wheel. The team had already used radiocarbon dating to test samples from fire hearths and tamarisk wood roofing found inside the stone circle. Nabta Playa had dozens of standing stones, all a few feet tall. Some of them lined up exactly with the sunrise on special days, and others matched up with bright stars in the sky. Inside the big circle, there were 6 special stones that may have been used for rituals or marking important times of the year. Around them, 29 standing stones might have worked like a simple calendar to help people know when it was time for something important, like the summer solstice, the longest day of the year. When the sun rose in just the right spot, it was a sign that the rainy season was coming. The stone circle once aligned with the brightest stars in the northern sky: Arcturus, Sirius, and Alpha Centauri. Some stones even pointed to the constellation Orion. By tracing Arcturus's movement across the sky, they figured out that it matched perfectly with the circle around 4800 BCE. That means it was the oldest astronomical site ever discovered. And the people of Nabta Playa may have been watching the stars thousands of years before telescopes were even invented. It looks like it had a huge meaning for people living and traveling through the desert. Over 10,000 years ago, the long, cold, and dry ice age that lasted for tens of thousands of years was finally fading away. Northern Africa got massive monsoons and rains that filled up seasonal lakes. So, parts of the desert turned into short-lived oases. For the nomadic people who roamed this harsh land, these summer rains were everything. Their entire way of life revolved around cattle. When archaeologists opened the central tomb at Nabta Playa, they dug up cattle bones and even a massive rock carved into the shape of a cow. The people who built it used the stars to guide them and find hidden watering holes like Nabta Playa, which likely held water for about 4 months a year, starting with the summer monsoons. But there was no North Star back then, so instead they navigated using bright stars and the way the sky seemed to spin in circles above them. When the lakes were full, the standing stones would be partly submerged, and from the western shore, you would see the reflection of the stars on the dark water. Nabta Playa is way less famous than Stonehenge, perhaps because its stones were buried and the famous site in England was open to visitors for thousands of years. Sadly, when Nabta Playa did become famous, some tourists ruined parts of it by moving stones around, which messed up the ancient star alignments. To protect it, the authorities moved everything to a museum where people can see the stones and the carved cow statue without damaging them. The Egyptian observatory isn't the only construction similar to Stonehenge. It has versions that were used for different purposes, from Germany and France to the US and the Andes in northern Peru. This last one is actually one of the oldest big structures ever built in this region. The circular plaza is made of two giant stone walls arranged in a ring. It was likely used for ceremonies and gatherings. Scientists have carbon dated it to be about 4,750 years old, which means it was built before the Great Pyramids of Egypt and Stonehenge. The plaza had two entrances and a special layer of clay, soil, gravel, and charcoal underneath. It was carefully planned and built. Archaeologists also found ceramic pieces, quartz crystals, and gemstones at the site, so it was definitely a special place. People visited it for centuries, but at some point it was sealed off, probably because of changing beliefs and traditions. The most recent discovery was the remains of a large timber circle roughly the same age and with parallels to Stonehenge, all the way up in Denmark. This open-air structure was likely part of a special area where prehistoric people from the late Neolithic and early Bronze Age gathered for rituals and ceremonies. The circle was made up of 45 giant wooden posts, forming a huge ring about 100 feet wide. The wood is gone now, but scientists believe tall timbers once stood in the holes and created an impressive wood henge. No one knows exactly what these circles were used for, but archaeologists have found animal bones and food remains at similar sites. So people probably used to gather there for feasts and rituals. In 2024, scientists found two ancient stone circles from the Neolithic period in Dartmoor National Park in England. Some archaeologists believe they might form a sacred ark. Many of Dartmoor's stone structures were built in a curved shape on the high ground in the center of the area. A long time ago, Dartmoor was covered in forests, so people may have used the high ground as important markers. One of the newly found circles fits inside this ark, but the other one is outside of it, to the north. This could have been an entrance point into the ark. There's also a raised bank of earth near the stones, which looks similar to other famous Neolithic sites, like the Ring of Brodgar in Scotland and Stonehenge itself. This means the people who built these circles may have visited Stonehenge or been inspired by it. Archaeologists in Oman found ancient stone monuments called tralith, which got the nickname Arabian Stonehenge. They were finished about 2,000 years ago, but no one knows for sure who built them or why. Scientists also found stone hand axes that are incredibly old, between 300,000 and 1.3 million years old, from the time when the first humans left Africa. At another site in central Oman, archaeologists discovered a Neolithic tomb from around 5,000 to 4,600 BCE. There are two chambers with the bones of dozens of people inside beneath a giant megalithic structure. Nearby, they also discovered rock carvings that were made by people who lived in the area. And then there is another Stonehenge look-alike, this time in Saudi Arabia, that was used as an apartment complex thousands of years ago. Archaeologists discovered a total of 345 stone circles by looking at aerial photos of a lava field. Each circle is between 13 to 26 feet and has at least one large standing stone in the middle. These structures still have remains of stone walls and doorways. Stone circles like Stonehenge are often linked to ceremonies and rituals, but scientists say that many early houses were actually built in round shapes, and rectangular homes only became common much later in history.
The Sahara Desert is like a Mad Max movie. Scorching heat, endless dunes, and an overall barren wasteland. A place where no one could live, right? Well, forget all you know about it, because 5,000 years ago, the Sahara was a lush paradise of grasslands, lakes, and rivers, and the home of a ghost civilization that vanished without a trace. Our tale begins in the 1930s, when a Hungarian explorer stumbled upon a cave in the middle of the Sahara. Inside, he found something bizarre: ancient rock paintings of people swimming in a lake, surrounded by giraffes, hippos, and crocodiles. At the time, everybody shrugged it off as some symbolic depiction of the afterlife, because, really, who would imagine a lake in the Sahara? Well, fast forward some 70 years later, when a group of archaeologists made a discovery that flipped the script. In a rock shelter in Libya, they unearthed 15 mummies, along with baskets, ceramic pots, and other everyday items. This may look like prehistoric junk to most people, but to archaeologists, it was like uncovering a key piece of evidence. Those people weren't just passing through, they lived here. You see, those weren't just any mummies. They were some of the oldest naturally mummified humans ever found, dating back over 7,000 years. Take that, Egypt. 2 of them still had readable DNA, preserved thanks to a rare natural mummification process, almost a miracle considering the Sahara's climate's ability to turn everything into, well, beef jerky. Scientists struggled to understand where those mummies came from for a while, because the mitochondrial DNA they recovered was not helpful at all. But thanks to scientific progress, they eventually managed to do a full genome analysis that revealed some weird secrets. Those people belonged to a human lineage that was completely unknown, and they lived isolated from the rest of humanity for thousands of years. For decades, researchers assumed that the place where they lived, the Green Sahara, was like a prehistoric highway, a lush corridor that humans and animals used to migrate between sub-Saharan Africa and the Mediterranean. But the mummies demolished that theory, like a hippo sitting on a sandcastle. Their DNA showed zero genetic mixing with sub-Saharan and Eurasian migrants, keeping their genes pure for 7,000 years. Their closest genetic relatives weren't their neighbors living right below the famous desert, but some ancient hunter-gatherers from Morocco, and even some guys that lived in the Czech Republic, when it wasn't even a country yet, 50,000 years ago. We're not out of the woods yet, because those mummies also carried some teeny-tiny traces of Neanderthal DNA, just 10% of the amount found in modern Eurasians. Now, if you paid attention in school, then you know that Neanderthals lived in Europe and Asia, and early humans only mixed with them after migrating out of Africa. But those Green Sahara folks never left Africa. So how did they get Neanderthal genes? The leading theory is that their ancestors mingled with Neanderthals in North Africa 50,000 years ago before settling in the Sahara and cutting off contact with the outside world. Archaeologists also found cattle bones and tools made of stone and wood at that rock shelter, proving that those people led a thriving pastoral lifestyle. This discovery made scientists scratch their heads for a while because, you see, animal domestication was not developed in Africa. So how did they learn it if they never mingled with anyone? Did they have ancient YouTube tutorials? Probably not. The researchers believe they must have traded knowledge with neighboring groups, but just knowledge, no saliva. It's almost too hard to believe that no outsiders mixed with them. After all, who wouldn't want to live in a thriving civilization in the middle of a green paradise, drinking milk, eating meat, and even using animal blood as a protein source? Ooh, yummy. They didn't have to hunt for every meal, thanks to their livestock, and the abundant water made life pretty sweet. And yet, they never married outsiders. Why? Maybe it was a cultural choice to never date outside their own group. Or maybe the landscape itself kept them isolated. This is where scientists place their bets. They believe that the dense forests and rivers that existed in the Green Sahara acted like nature's no trespassing sign, creating a geographical barrier that isolates animals, plants, and whole societies. This isolation is the reason why their genes were so unique. These guys weren't swapping spit with anyone else. But this genetic time capsule almost didn't survive. For most of the last ice age, the Sahara was even harsher than today, a true dead zone where humans couldn't survive. 70,000 years ago, even the toughest people disappeared, retreating to the Nile Valley and the Mediterranean coast. Why? Because Earth was a climate bully. Massive glaciers stole all the moisture, weakening monsoons until rain clouds barely reached North Africa. Then came the knockout punches. Armadas of icebergs flooded the North Atlantic, triggering devastating droughts each time. This was the Sahara's ultimate keep-out era. Now, you're probably wondering how in the world the Sahara turned green after all this, and then went back to being a desert again. Well, it all started 15,000 years ago, I wasn't around then, when Earth was shaking off the last ice age. Our planet's axis was a bit wobbly, and because of that, the northern hemisphere got closer to the sun, getting extra sunlight and heat. This eternal summer turned North Africa into a giant moisture magnet, pulling water from the Atlantic and making it all rain down on the Sahara. The result of this ridiculous amount of rain was a lush savanna, complete with lakes the size of small countries. But the African humid period was not just a one-time miracle. The truth is, this eternal on and off switch between green and desert happened to the Sahara more than 230 times since the desert was born. During one of these events, the Sahara even expanded, getting bigger than it is today. So when the Green Sahara showed up, you can bet it brought the ultimate ecosystem glow-up. This wasn't just a light dusting of grass. We're talking full makeover. The transformation was so complete, it even reshaped animal populations. Cheetahs suddenly struggled with the new prey dynamics, while rodents like the multi-mammate mouse thrived in the suddenly abundant grasslands. But don't pack your prehistoric swim trunks just yet. This paradise had teeth. The Sahara was an ecological maze of crocodile-infested rivers, malaria-carrying mosquitoes, and big cats lurking in the tall grass. Crossing it would have been like playing a real-life game of Hungry Hungry Hippos. This is probably why more groups didn't settle permanently. The Sahara's climate cycled between wet and dry every 20,000 years, hardly a stable zip code. For most ancient people, it was smarter to treat the Green Sahara like an all-you-can-eat buffet, grab resources and leave before the desert returned. Still, this Green Sahara period lasted for 10,000 years, giving our mystery shepherds plenty of time to thrive. But around 5,000 years ago, Earth's axis shifted again, the rains moved away, and the Sahara dried up faster than a puddle in July. As the desert returned, the shepherds from the Green Sahara had no choice but to pack up their livestock and leave. Some researchers believe they migrated toward the Nile, laying the groundwork for ancient Egypt, so I guess their legacy lives on. Besides, their pure lineage may be extinct by now, but some faint genes of the mummies can still be found in the people that live in North Africa today. But the introvert mummies were not the only ones using the Green Sahara as an Airbnb. They actually had neighbors just around the corner, in a lakeside village in Niger to be exact. Those people thrived for 5,000 years and left behind the oldest Sahara Desert cemetery, including a man buried in a turtle shell, a grinning Halloween man with filed teeth, and a heartbreaking family embrace frozen in time, victims of the very waters that sustained them. Eventually, those people disappeared too, just like it happened to our antisocial friends. This proves that this desert outsmarts everyone, with a landscape that gives paradise with one hand and takes it away with the other. So, let's consider velociraptors as pets. Yeah, walking your dino in the park, playing fetch, and we probably could have it now if it hadn't been for those pesky asteroids. To be fair, we ended up with mammals, which, let's face it, it was a pretty solid trade. But here's the big question. Why didn't reptiles make a grand comeback? Why did mammals rise instead? The answer, believe it or not, involves fungi. Yup, the same stuff that gives you athlete's foot and ruins your leftovers also wiped out dinosaurs. Welcome to the weirdest twist in extinction history. It all started with a very bad day 66 million years ago, when a 9-mile-wide asteroid crash-landed in what's now Mexico. The space rock was moving so fast that it vaporized on impact, punching out a crater 10 times its own size. Now, if you remember anything from your physics class, and no judgment if you don't, high speed means high energy. And that energy turned into a blast wave and heat so intense it could have cooked anything in the area instantly. And it didn't stop there. Tiny molten rock beads rained down globally, generating radiation equivalent to 20 million megatons. Forests caught fire, wildfires raged across continents, and the sky filled with soot and sulfuric acid. Earth turned into a planetary air fryer. Then came the blackout. With all that debris in the atmosphere, half of the sunlight couldn't reach the surface, making sea surface temperature drop by 13 degrees Fahrenheit. Within just a few weeks, the planet entered a literal impact winter. There was no sunlight for at least 2 years, and Earth experienced a 15-year-long climate collapse while the dust slowly cleared. 75% of all animal species completely disappeared. Those that survived the initial blast faced tsunamis, starvation, and the collapse of entire food chains. If you were a big animal, say over 55 pounds, your chances were basically zero. And if you were a plant, forget about it. No sunlight means no photosynthesis. And that means no plankton, no trees, no grass, and eventually no herbivores, which means no carnivores either. It was a domino effect straight into extinction. The Earth became a cold, dark graveyard. But there was one organism that looked around and said, "Yeah, this is perfect." And it was fungi. Now, fungi thrive in moist, dark, and decaying environments. You know, like a world blanketed in ash full of dead trees and rotting animals. With no sunlight and plummeting temperatures, fungi had a once-in-a-lifetime chance to take over. And they did. Fossil records show widespread fungal contamination in the period after the impact. It was a global fungal bloom, like the moldy icing on an apocalyptic cake. Now, this was great news for fungi, but terrible news for reptiles. See, fungi aren't just harmless mushrooms. Many are pathogens, and they love cold-blooded creatures. Reptiles, including some of the dinosaurs that survived, were ectothermic. This means that they relied on external heat sources to warm their bodies. In a normal situation, a nice sunny rock would do the trick. Bask in the sun, raise your internal temperature, and fight off infections. It's like an induced fever, because, unlike mammals, like me, their bodies don't do it for them. And yes, I'm a mammal too. But there was no sun, remember? And a cold reptile is a sluggish reptile. Their metabolism slows down, which might sound like a good thing, because it means they can survive on less food and oxygen. But in this new hostile world, it was a disaster. They had less energy to move, less energy to hunt, and couldn't even digest food properly. Their bodies were colder, weaker, and easier for fungi to invade. Reptile reproduction was hit hard too. Most reptiles lay eggs, which are usually buried in the soil or left in hidden nests. But with the soil now damp, cold, and riddled with fungal spores, those eggs became easy targets. Spores penetrated the thin eggshells, destroying the embryos before they could hatch. So not only were adult reptiles struggling to fight infections, but their future generations were being wiped out in the nest. This vulnerability isn't just ancient history. We still see reptiles and amphibians struggling with fungi today. There's a type of fungi, hey, you try to pronounce this, that decimated frog populations. And reptiles in colder or poorly maintained environments have to deal with fungal skin infections. Which brings us to the protagonists of the era, mammals. At the time of the impact, mammals were tiny scrappy creatures about the size of a rat. But they had a secret weapon, actually several. First off, mammals are warm-blooded, something scientists call endothermic. They produce their own body heat, and that alone gives them a major edge, because most fungi can't tolerate temperatures above 98.6 Fahrenheit. So, while reptiles were freezing and being turned into fungal buffets, mammals were literally too hot to handle. Their warm bodies acted like natural shields against infection. And then there's reproduction. Mammals carry their young inside their bodies. This means that their developing babies were safe and warm, insulated from the hostile external environment, instead of being exposed to the unfriendly world, protected just by a fragile shell. No eggs? No problem. Their metabolism was another secret weapon. Their fast-burning energy systems let them move more, hunt more, and eat more. And because they were small, they didn't need a lot of food. And here's the cool part. Mammals probably ate fungi. Yep, the same organisms ruining the lives of reptiles. And this fungal diet might have helped them boost their immune systems, giving them an evolutionary edge. Over generations, this resistance was passed down, which explains why fungal infections mostly give us an annoying rash, but still wreaks havoc among reptiles. Of course, not all dinos were cold-blooded. In fact, some massive creatures, like the T-Rex, were warm-blooded. But, warm-blooded or not, their size worked against them. You know, giants need giant meals, and in the post-impact world, those meals didn't exist. Being warm-blooded helps, sure, but not when you're too big to feed. Small dinosaurs, however, were a different story. Some survived, and we call them birds. Their small size meant they were lighter and needed less food, and their feathers helped with insulation. Being able to fly was also a flex, since they could reach food in higher places. Their beaks and guts were adapted for flexible diets, and bigger dinos were definitely picky eaters. Evolution did its thing, and the line between birds and dinos blurred forever. The same survival playbook worked for mammals. Small size? Check. Safe reproduction? Check. Versatile diets? Double check. While the rest of the world was on pause, mammals scurried through the underbrush, dodging disaster and waiting for the dust to settle. And then, it did. The sun eventually came back. Plants started growing again. Life rebooted. But this time, the stage was different, with big reptiles mostly gone. No more towering predators, no more thundering herds of horned beasts. Mammals had room to stretch, and they did. They grew fast, but not too fast. Mammals never got dinosaur-sized, and that's not a coincidence. Large herbivores today, like elephants, have it easy since their food doesn't run away from them. But large predators are rare for a good reason. Hunting is hard. Your prey sees you coming, so you can't be a big, tall dummy running around. Besides, you need energy to chase, stamina to fight, and a metabolism to match. And you know how that worked out for dinos. Not to mention, mammal bones aren't built like dinosaur bones. The latter had hollow structures, even air sacs, to support their size. But if you stack too much weight on a mammal's bone, it'll snap. Nature has limits, and mammals have learned to work within them. So, when the light returned, reptiles were fewer and more fragile, clinging to the edges of ecosystems. Mammals, on the other hand, were everywhere. Before the asteroid, dinosaurs kept mammals small, and mammals, well, they didn't get much say about that. But now, with the giants gone, mammals could finally level up. And fungi? Well, they stuck around too. But mammals had already passed the ultimate test and came out on top. Thanks to their body heat, internal babies, flexible diets, and a little help from some deadly mushrooms, mammals inherited Earth. So yeah, no pet velociraptor. But maybe that's okay. You got a cat, right? Close enough. Actually, I think dogs are better. How do you feel about that? Let me know in the comments. Stone Age people were grunting cavemen with spears. True or false? Absolutely false. They were gathering around and forming real culture as far as we've discovered. In Turkey, scientists uncovered a 12,000-year-old mystery that's revising history. It's a sophisticated cosmic calendar made out of giant stone temples that may actually be a warning from the stars. We're talking about Göbekli Tepe. This prehistorical site predates even Stonehenge, our classical stone ring circle, by 6,000 years. And it upends why we think Stone Age civilizations emerged and thrived. Here's how this discovery could change our collective history. Around 10,850 BCE, a massive comet, or better yet, a bunch of comet fragments, smashed into Earth. The skies darkened, the temperature dropped, big animals vanished, and it kicked off a mini ice age that lasted over 1,200 years. What's now a place called Göbekli Tepe was home to a group of humans who survived this entire chaotic event. After it happened, they started paying close attention to the sky. As a way of trying to control time a little bit more, they tracked the movements of the sun, the moon, the planets, and comets. This in turn led them to build a huge lunisolar calendar, the first one in the world. Now, if you were to tour around this classic Stone Age monument, you'd see that not all the stone pillars are blank. Some of them have carvings, like this main one with a bunch of V's on it. Turns out there are 365 V's, which scientists believe represent the days of the solar year. One of them, a V hanging on a bird's neck, is thought to mark a solar eclipse. Other pillars have dangerous animals carved on them, like foxes, lions, scorpions, vultures, twisting and crawling up the sides. Unlike typical Stone Age carvings, these weren't of edible animals like deer or sheep. One of the theories is that these drawings were symbolic. Some archaeologists believe they reflect the fears and chaos this civilization had lived through, a kind of collective attempt to make sense of a terrifying and unpredictable world. Archaeologist Danielle Stordur has highlighted the images of vultures, saying they represent the people who passed away. In some ancient cultures, vultures were believed to carry the souls of the deceased into another realm. She's seen similar symbols in ancient sites nearby. To understand why this all makes sense, we need to dig deeper into the real purpose of this site. Göbekli Tepe was discovered in 1994 by German archaeologist Klaus Schmidt, who realized that the hill in southeastern Turkey wasn't just another Neolithic mound. Underneath it, his team uncovered massive stone circles supported by pillars weighing up to 20 tons. Radiocarbon dating puts the site at around 12,000 years old, making it the oldest known ceremonial structure ever built. I mean, it predates the Egyptian pyramids by over 7,000 years. This discovery shocked the archaeological world. At the end of the Ice Age, humans were supposed to be nomadic, surviving off wild plants and animals, not building sacred complexes with symbolic art, and giving birth to what we now classify as civilization. We usually think civilization starts with farming, then villages, then crops. But this site suggests something more surprising. Early humans may have come together not to grow food, but to worship. Schmidt found no signs of homes, hearths, or permanent settlement, just stuff used for rituals and gatherings. This has led researchers to believe that spirituality and communal rituals came first and that farming followed. Because to build something this massive, you'd need hundreds of people working together, which in turn would have sparked the need for food, organization, and social structure. In other words, the temple came first, then the village, then the farm. Now, Göbekli Tepe isn't just stirring debate because it's old. It's because it seems too advanced for its time, and that's where the more controversial theories start to emerge. Some researchers believe the builders of Göbekli Tepe weren't simply primitive hunter-gatherers experimenting with stone tools. They may have been the inheritors of ancient knowledge, remnants of a much older civilization that existed before the end of the last ice age. This idea ties into the Younger Dryas impact hypothesis, a theory that a comet struck Earth around 10,850 years ago, triggering a sudden and catastrophic climate shift. According to this view, the survivors of that event passed down their knowledge through symbolism, architecture, and oral tradition. And Göbekli Tepe could be one of the earliest attempts to preserve that memory. Now, if that's true, then the carvings at this site, especially the animal symbols on the pillars, aren't just decorative. They could be astronomical codes, tracking constellations and celestial events. But one pillar might hold the biggest secret of all. It's called the Vulture Stone, and it's freaking archaeologists out. On it, you'll find a strange combination of figures: a headless man, birds, and a scorpion. To the untrained eye, it might seem random, but some researchers believe these are ancient representations of constellations, like Scorpius among them, and that the headless man symbolizes a mass extinction event. Some even argue that this is the oldest known record of a comet impact, the one that triggered the Younger Dryas. And if you're wondering who this older lost civilization might have been, they are called Atlantis, or more neutrally, Civilization X. Theorists like Graham Hancock suggest that this advanced culture, destroyed in the chaos of the comet impact, passed fragments of its knowledge to survivors around the globe. In that case, Göbekli Tepe wasn't the start of civilization, it was the restart. Now, back to the stones. Pillar 43 may look like a celestial calendar at first, but when archaeologists recreated the sky patterns encoded in its carvings, they found a precise snapshot of the sky dating back over 13,000 years. It appears to show a meteor shower, a flood, and humanity's tragic end, aka the Headless Man. A snake rising from the ground might even symbolize tidal waves or destruction coming from below. But the story doesn't end there. Pillar seems to expand on the same disaster, the one they called the Terror of the Sky. You might see animals fleeing, waves, fire raining down. It paints a vivid picture of the meteor shower. But wait! While Pillars 43 and 56 may encode memories of a past catastrophe, Pillar 18 might be a forecast. That stone zooms in on the Aquarius constellation. If this sounds familiar, maybe it's from the phase Age of Aquarius, which is the age we're living in now. Some enthusiasts believe this may be a warning for us, and may be telling us that a similar meteor shower will hit Earth and thus you and me and us. I mean, chills! But hey, that's the kind of mystery that makes Göbekli Tepe so captivating. Today, archaeologists know that Göbekli Tepe was part of a much larger sacred complex, now known as Taş Tepeler. A network of ancient sites across the region, each with its own secrets and structures, but connected by shared patterns and motifs. In 2019, excavations began at this sister site, just 40 miles from Göbekli Tepe, known as Karahan Tepe. And here's the twist. Some researchers believe Karahan Tepe might be even older. Unlike Göbekli Tepe, which appears to have been primarily ceremonial, Karahan Tepe has signs of domestic structures like walls, tools, and perhaps even homes. And that changes everything. Because whether these sites were the work of highly sophisticated hunter-gatherers or survivors carrying the fragments of a lost pre-Ice Age civilization, one thing becomes clear. Our ancestors weren't just surviving. They were planning, tracking, and predicting. They were far more capable, curious, and connected to the universe than we ever gave them credit for. Well, here you are, on a week-long trek through the Himalayas. You're exhausted. The cold is cutting through to your bones, and suddenly, you stumble upon a human skeleton near a lake. You look around, and there are dozens, maybe even hundreds of bones scattered across the ground. Well, guess what? This really happened in 1942 with an Indian forest official. Since this chilling discovery, researchers have been trying to figure out how so many people lost their lives in such a remote, isolated spot. So, what happened up there? We're talking about Rupkund, a lake sitting at over 16,000 feet in the Himalayas. But it's not just known by that name. People also call it Mystery Lake, or even more bizarrely, the Skeleton Lake. This place is remote, I mean really remote. It's not just because it's insanely high up, but also because it's surrounded by snow-covered mountains. Now, if you're planning to go there, make sure you have some solid hiking shoes. It's a week-long trek covering more than 30 miles of tough, rugged terrain. Along the way, you'll pass through all kinds of challenging landscapes: moss-covered oak forests, misty fields with an eerie vibe, and up at the top, snow. The highest point of the trek is a knife-edge ridge called Junargali. Just below that lies Rupkund. The closer you get to the lake, the darker the atmosphere feels. And on the ground, you can find human skeletons scattered around, belonging to more than 300 people. Along with them, there were things like wooden artifacts, leather slippers, and rings. Okay, so something really macabre happened here. But what? Well, we have three main theories. Theory number one, the local legend. According to this story, A long time ago, a king named Raja Justival went on a pilgrimage deep into the Himalayas to reach a sacred mountain temple. He brought his pregnant queen, Rani Balumpa, along with a group of servants, dancers, and others. While they were up in the mountains, a massive hailstorm hit, or as the legend goes, an angry deity started hurling iron balls from the sky. Either way, the storm was brutal, and they had nowhere to take shelter. In the end, they all lost their lives near the lake. Theory number 2, an escape route. Some say the remains belong to Indian soldiers who tried to invade a foreign territory back in 1841, but they were defeated. Over 70 of them were forced to make their way back home through the Himalayas, and they met a tragic end along the way. Theory number 3, a mass grave. This theory suggests that some kind of widespread health issue hit the group. They were all buried there, in isolation, to prevent the disease from spreading. In this case, Rupkund Lake and its surroundings would basically be a cold, remote cemetery. Now, do you know what all these theories have in common? They all assume that the skeletons belong to a single group of people who died in one catastrophic event. But then science came along and things got way creepier. In 2019, 28 scientists from institutions in the US, India, and Germany teamed up for 5 years to figure out what the heck happened up there. They studied the remains of 38 individuals, 23 men and 15 women. And right there, we can already toss out theory number 2. That's important because if these people had been soldiers on a military mission, you would expect most, if not all of them, to be men. Armies in the past were almost entirely male. But here, there were just too many women for that to make sense. And on top of that, no signs of combat or military gear were found at all. After a genetic analysis, researchers noticed that the individuals weren't part of the same family, at least not by blood, like third-degree relatives or closer. And most importantly, they were mostly healthy. These two facts help rule out theory number 3. It probably wasn't some kind of highly contagious health problem. But the most shocking part is that these skeletons didn't belong to just one single group. They actually came from 3 distinct groups. The first group had ancestry that falls within the range of present-day South Asians, basically from the regions that are now India, Pakistan, and Nepal. The second group had ancestry typical of Eastern Mediterranean, just like people from today's Greece, or more specifically from Crete. And they also identified one individual with Southeast Asian-related ancestry. The dating also shows that these remains weren't deposited at the same time. In other words, groups 1 and 2 didn't live during the same period. Their deaths were actually spread out over as much as 1,000 years. Oh great, now theory number 1 is out the window too. After all, the studies can confirm that these people passed away in at least 2 separate tragic events. According to the researchers, there is a possible clue about where at least some of the people with South Asian ancestry might have come from, or why they were even up there in the first place. Rupkund Lake isn't part of any major trade route or anything like that, but it is along the path of a pilgrimage called the Nanda Devi Raj Jat. It still happens today, once every 12 years, where people hike through the mountains for worship and celebration. Now, the written records of this pilgrimage only show up around the late 1800s, but there are inscriptions in nearby temples that go way back, like to the 8th or 10th century. So, it's possible the tradition started much earlier, and maybe some of these people passed away during one of those early pilgrimages, due to a heavy storm or some other natural disaster. Okay, but how do we explain the group that came from Greece? Well, that's definitely more puzzling. First, because there aren't any historical records or evidence to explain who these people were or what they were doing in the far reaches of the Himalayas, so it's hard to know where to start. The study suggests that they could have been a group of unrelated men and women born in the Eastern Mediterranean region around the time the Ottoman Empire controlled that area. The evidence suggests that they had a diet mostly based on land-based foods, not the seafood you would expect from people living near the coast. So they might have lived inland and somehow ended up in the Himalayas, possibly traveling for reasons that researchers can't fully explain yet. The best guess is that they were also participating in a pilgrimage. But honestly, it seems pretty unlikely that people from Europe would have traveled all the way to Rupkund just to do that. And let's assume they did. What exactly happened to them? I mean, how did they all pass away in the same exact spot? Well, the researchers can't say for sure, but people online love to speculate. You think? Some suggest that they fell from the Junagarli Ridge, or since they were at such a high altitude, maybe they passed away due to acute mountain sickness. Up there, the oxygen levels are much lower, which can lead to things like headaches, vomiting, and dizziness. The problem is, it can escalate quickly, and if it affects your lungs and brain, it can become life-threatening. So yeah, it could have happened. But it's still strange to think it happened to so many people all at once. We definitely still need a lot more answers when it comes to Rupkund. But one of the obstacles researchers face is that the site remains highly disturbed and unpreserved. Over the years, trekkers have moved around the skeletons, or worse, some have even taken them home as macabre souvenirs. But the more we mess with those remains, the harder it becomes to find an accurate answer in the future, no matter how much science advances. So, for now, the Mystery Lake will remain exactly that, a big mystery. Time can stretch or shrink depending on where you are. Climb to the top of an extremely high mountain, and time will pass a teeny tiny bit faster than if you were down in a valley. That's all because of gravity and how it affects time. We hardly notice it in our everyday life, but for scientists and space agencies preparing to send people to the moon, these minuscule differences in time really do matter. We'll get to answer the why question a bit later. Right now, a new space race is underway. Many countries want to establish long-term bases on the moon. With humans up there, things like reliable timekeeping become crucial. The thing is, the moon doesn't operate on Earth's time. A day on the moon runs slightly faster than a day on Earth. The difference is about 56 microseconds, and it seems insignificant. But over time, even such a difference can add up, creating bigger issues. So, to keep lunar missions running smoothly and prevent things from drifting out of sync, NASA and scientists around the world are now dealing with a tricky challenge, creating an entirely new lunar timescale. NASA is supposed to start using it by 2026. It's the same year they hope to send astronauts back to the moon for the first time in 50 years. But this new timescale is not just a moon time zone. It's actually an entire system that will adjust for the moon's faster time and keep everything synchronized with Earth's time systems. Only in this case will missions be able to run smoothly. You see, on Earth our timekeeping is already surprisingly complicated. It might seem like time should be a straightforward concept, but keeping accurate time is actually a precise science, especially when you consider how much timekeeping affects our daily lives. So to keep global time coordinated, scientists rely on something called Coordinated Universal Time, also known as UTC. This global time standard is based on ultra-precise atomic clocks that scientists place in separate locations all over the world. Atomic clocks are cool because they measure time based on the consistent vibrations of atoms, so they're super stable and accurate. This helps scientists make sure UTC is the same for everyone everywhere. These atomic clocks also take into account that time moves slightly more slowly the closer you are to the center of our planet. So, atomic clocks positioned closer to the Earth's surface tick a bit more slowly due to stronger gravitational pull. This effect, explained by Einstein's theory of relativity, happens because gravity affects time. By spreading atomic clocks across different elevations, scientists average out all the tiny time differences caused by gravity. Also, for precise timekeeping, scientists occasionally add leap seconds to account for the small natural changes in Earth's rotation speed. It sounds pretty technical, but this process of keeping everyone on the same time helps make the modern world function. After all, precise timing is crucial for global trading, GPS navigation, and even internet communications. But time on the moon works differently. Our natural satellite has a weaker gravitational field than Earth. That's why clocks on the moon tick a bit faster. This difference means that lunar clocks are very likely to slowly drift away from Earth clocks if there's no correction. It can lead to big problems when astronauts need to keep in close contact with Earth or navigate around the lunar surface. NASA's solution is something called a lunar time scale. Scientists aren't going to adjust moon clocks to match Earth exactly. Instead, they want to establish a unique system that measures lunar time accurately, but is also easy to convert back to Earth time. Think of it as creating a whole new framework just for the moon. To make this lunar time system work, NASA is cooperating with international colleagues like the European Space Agency. Together, they're setting up what they call LunaNet. This lunar network will be a bit like the Internet for the moon. It'll make sure all the lunar clocks work together and align with Earth-based time. Just like how atomic clocks around the world coordinate for UTC on Earth, clocks on the moon will be part of this larger LunaNet network. Now, scientists are pretty experienced when it comes to managing time in space. Global Positioning System satellites, which orbit Earth about 12,550 miles high, have atomic clocks on board. These clocks tick faster than clocks on the Earth's surface because they're quite far away from Earth's gravitational pull. But then, how does GPS navigation stay accurate? It's because scientists have figured out ways to slow those clocks down to match Earth's time. This experience with GPS clocks is a great base for what scientists need to do on the moon. In some ways, it might be even easier than managing GPS. Scientists can work with lunar clocks as they naturally are, instead of needing to adjust them to sync perfectly with Earth. By setting up accurate lunar time from the start, scientists hope to avoid some of the complications of managing GPS satellites. And now, here's the interesting part, or maybe more interesting. To keep lunar timekeeping a reality, NASA and its partners want to set up clocks both on the lunar surface and on satellites orbiting the moon. Some of these clocks will be long-lasting atomic clocks, and others will be crystal oscillators. Those offer stability over short time periods. Together, these clocks will create a network that scientists will be able to rely on. Meanwhile, atomic clocks for space don't come cheap. They can cost a staggering few $1,000,000 each. Luckily, crystal oscillators are more affordable, but they don't stay accurate over long periods. Once those clocks are set up, they'll work together as part of LunaNet, which will be NASA's framework for everything related to moon-based time and data networks. LunaNet will act like an internet for lunar operations. Different space agencies will contribute to it, like how internet service providers work for us on Earth. But there's another set of challenges, and it's connected with the moon's rotation. Firstly, a day on the moon lasts much longer than a day on our planet because it takes the moon about 28 Earth days to make a full rotation. Plus, the moon's equator experiences about 14 days of sunlight, followed by 14 days of darkness, unlike Earth's regular day-night cycle. And at the moon's south pole, where NASA is going to establish future lunar missions, there are areas that stay lit or in shadow permanently. It might make it harder for astronauts to keep track of time. NASA and its partners hope to involve more countries in this project through international organizations like the International Astronomical Union. The idea is to get as many countries as possible on board with the lunar timescale, so that everyone exploring the moon is on the same page. Now, another really exciting thing about all this is that figuring out lunar time could help other future space missions, like trips to Mars. The experience and knowledge we'll get from setting up a lunar timescale are likely to serve as a blueprint for managing time on even farther planets. That's one of the reasons why scientists are taking this lunar project so seriously. As for astronauts living on the moon, a consistent, reliable time system will be essential, not just for navigation, but for everything from scientific experiments to day-to-day activities. NASA's Lunar Time Project is truly groundbreaking. It's the first step toward managing time as humans expand farther into space. And if they get it right, it'll mean that future astronauts won't just have Earth time to guide them. They'll also have a moon time, and even, one day, a Mars time too. Precise timekeeping matters both for the sake of scientifically understanding the passage of time on the moon and for setting up all the infrastructure necessary to carry out missions. Scientists are also eager to create a timescale from scratch because they can take everything they've learned about timekeeping on Earth and apply it to a new system on the Moon. Well, I'm out of time, so bye!
Soon we might start constructing loads of stuff on the Moon. All because India's moon mission has recently detected sulfur near the Moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the Moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the Moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the Moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the Moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the Moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the Moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the Moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the Moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the Moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar-penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the Moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
Our moon exploration project started out in 1969. Sure, There have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon using data previously collected by NASA. And what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8. 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected. But if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptic.